Now it's not about food truck and not about the event in the evening. It's about the next session that is indispensable for every Ceph admin. Please welcome Tobias Brunnwieser, infrastructure engineer at the object storage team at Hetzner Cloud, where he's building an S3 compatible product on top of Ceph. He's presenting how RADOS Gateway stores S3 objects in RADOS. We'll take you on a deep dive into the RADOS Gateway internals. We all know RADOS Gateway stores S3 objects in RADOS, but Tobias will show us precisely which data lands where, in what format, and in which pool. The knowledge is golden for effective troubleshooting. Welcome, Tobias Brunnwieser from Hetzner Cloud.
Hello. So, first of all, why would you even want to know this? If you probably know that a RADOS Gateway is definitely built to be scalable, and there are a lot of knobs you can tweak to achieve that. But unless you know what is in the data pool, you maybe are not even aware what you're changing there or what you're affecting there or what your actual bottleneck is, contrary to what the internet recommends. And you probably also have been in the situation that you have like a bucket that is bust and you want to rebuild the index. Maybe you want to know what's happened. Or maybe you want to determine in the first place if it's actually completely broken or if something else is wrong with it. And I hope to shine a little bit of light on that, so you maybe have the better understanding to determine such things. Before we can talk about any detail, we have to first talk about Ceph pools. And if we talk about RADOS Gateway, we're talking mainly about two different categories of pools that RADOS Gateway is using. The first of all is an OMAP, a replicated pool, because RADOS Gateway makes heavy use of OMAPs. I don't know if everybody else here in the room is even familiar with that, because it's like not the most common feature. But just like accept it. And of course, everything else goes into a Erasure-coded pool usually, because we have only so much money to buy disks, and we want to be efficient. So I want to go through this by pool, and we start with a relatively easy pool. That's the user keys pool. And you see there, it has a certain structure. The first is the zone. Most of you probably never even touch this because you're not running multi-site, so it's usually just default. But if you have a multi-site setup, then the zone name is encoded in most of these pools. And then there is this fishy thing behind the colons. Pools in RADOS can have namespaces. And namespaces isolate different objects within the very same pool. And RADOS gateways make heavy use of that to isolate different categories of data. We will get to see some couple of other namespaces as well. So here we have this users.key namespace. So let's have a look. So this is the command to list the contents of that pool. In red, I have highlighted to use the namespace. If you don't pass this namespace argument, you will get completely different data. And what we can get here? Oh, that looks like an access key, because actually it is, if you just cat it, you get a user ID. So it's a mapping from access key to user ID. So if you get a request from the outside, then you can make a lookup and fetch the corresponding user. So next pool, user metadata. Again, the zone is in there, and then users.uid namespace. Relatively simple. Let's have a look. We get 2 entries per user, interestingly. and one that is named like after the user, and one that has these .buckets suffix there. The user object is relatively straightforward, I'd say. I mean, there's a lot of different information there, but yeah, we've got a username, there's a list of keys that the user owns. So far, so good. What's in those and that .buckets thing? Well, we can have a look again. And we see that's just an empty object. But it's not an empty object, it's just an OMAP. And we can use list OMAP keys to get all the members of that OMAP, and we get a list of buckets. So we have like a bucket map of a user. So if you use the list buckets call, I think it is, an S3 API, then you get a list of the buckets that the user owns. Next tool, bucket metadata. We are now in the namespace root. I think this is also the default namespace. You don't have to specify that one explicitly. And we get 2 entries per bucket that is known to RADOS Gateway. One that is named after the bucket, and one that has this weird.bucket.meta prefix, and then there's a colon, and then there's something that looks like a UUID. Let's have a look. So the my bucket thing is obviously bucket metadata. Who could guess that? And the other thing is bucket instance info object. Why do we need bucket instances? The thing is, like, you have certain situations where there are multiple versions of a same bucket in existence. For example, if you delete the bucket and recreate it, or if you have a multi-site setup, then you have like the same bucket in different zones, but they have different contents. And that's why there is different bucket instances for the same bucket. That's why we need to do that abstraction. And for like internal layout changes, which I get to a little bit later, then you also need a different bucket instance that replaces the old one. For our purposes, we are mostly bothered by the bucket instance because like there's all the details. So let's have a look at this. Yeah, there's the bucket name in there, in that name. And then there's something that's called a bucket marker. You maybe have seen this if you use the RADOS Gateway admin bucket stats command. There it is also included as a member in there. So what is in that object? Well, something like creation time, who owns that bucket, where to put the contents of the bucket, as if it's an HTTP or NVMe or whatever. The bucket layout, this is a different thing. Yeah, so also to do a lot of multi-site, but later. And this is the first time that we also need to have a look at extended attributes. Extended attributes are, as the name says, like it's just a key value thing that is attached to an RADOS object. And we can have a look at those as well with the list x command, and we get things like an encoding version. If you upgrade RADOS Gateway, then it probably, hopefully, recognizes, oh, this object is written in a different version, I can't read that. You've got the access control list, and if you just dump that X attribute, you can get the JSON back, exactly as you would expect. And I am policy, and I think that's it in this case. Okay, next pool. This is the pool probably most of you are familiar with. This is like the bucket index pool. We need an index where we keep track of which objects are part of the bucket. And that's that. That one must be on a replicated pool because it makes heavily use of OMAPs, and you see why shortly. So if we just list it, we get something like this. This is, well, UED-like thingy and a lot of numbers. And all of those are empty because they are OMAPs. Let's break the name apart. The first thing is relatively easy. This is just a static prefix, just chosen arbitrarily. Then we have the bucket marker again, if you remember. In the bucket metadata, we got the bucket marker. The bucket marker is now here. That identifies the bucket instance. So if we know we want to list the contents of one bucket, we just get the bucket marker, and then we can construct these the names of these objects up there. And that's actually the RADOS Gateway admin command to get the bucket marker of your own if you want to try. Then there's the bucket instance generation. That is in most cases not present, except if you're running multi-site. Then this number can change, and there's a magic command to retrieve the next generation. And we won't go to in any more detail to that, but I just tell you, like, this can happen, this can be there, and that's how you can get the name. And then we have a shard number, because bucket indices are sharded. And why do we shard? Because each index object, each of these RADOS objects you saw on the slide before, goes to a different PG, and if it's a different PG, it's a different OSD. And then we can exploit the parallelity of that for the bucket index. And how do objects end up in which bucket index? Well, we just take the object ID, this is more or less the name. We hash it, and then we take it modulo the number of shards we have for the bucket index, and you get your shard number. And within each of these bucket shards, the entries are sorted. So what we have, maybe have a look here. So this is a marker here, up here, and we doing the list OMAP keys on that thing for a given marker and a given shard. And then we get shard 1 that has like 3 objects that are sorted, and then we get shard 2 and has 3 objects and they're sorted. And what we're gonna need to do is, if we list the bucket index, we have a divide and conquer. Like, we fan out to all shards, get a certain number of entries for starting with a given key, and then we merge the results and give that back to the client. Okay, finally, data pool. So now we have talked like we know that the bucket contains certain objects. Now we need to find out like where are they stored or how they are stored. So here we've got multiple pools. Depending on the number of storage classes you have. Again, zone name, then the storage class. In most cases, it's just default or standard, whatever you configured. But if you have like 3 storage classes, then you have like 3 pools created for you automatically, and the data ends up in 3 different pools. Usually, you want to use erasure coding, obviously. There's an example with the famous high availability zone. Okay, so now it's getting a little bit more complex, and I have like this example object that's named 14 megabyte because it's like 14 megabytes of random data. And for this 14 megabyte objects, we have one entry in the bucket index in one of these shards. And now we need to find where the data is placed. And first of all, we have a so-called head object. And if you look at the head object, we have again this bucket marker. So every object in the data pool is prefixed with the bucket marker, so we can immediately find out to which bucket it originally belongs. That's also why you can actually rebuild the bucket index. Because what the RADOS Gateway tools do is they iterate through every object in the data pool, take that prefix, and then they can determine, okay, this belongs to that bucket, and then they can rebuild the index from that. But it's also super helpful for debugging, of course. And of course, the second part is simply the object name. So, but this is only the first of possibly multiple RADOS objects that represent one S3 object. Because there is striping, and this is the configuration option if you have ever seen that. It's by default 4 megabytes, I think, is still at the moment for Reef. But there are talks about increasing that. And this is optimized for the optimal I/O size of a pool, or that's how it's intended to be. Why are we doing that? Of course, if you have like a large S3 object, then we can again do parallel reads and writes to the very same S3 object, and it helps us with multi-part uploads as well, which you see in a minute. Okay, let's have a look at this head object. Again, RADOS command here. And we see in the attributes that there is further information. For example, access control list. Yeah, not surprising here, a content type, e-tag, and hash. That's all things you know from S3, and that's just simply added as extended attributes to the object. And, more importantly, there's a manifest. That manifest specifies, like, where is the rest of the data? Because currently, at the moment, we have not seen any bits of data from that object. You can have a look at the manifest with a RADOS Gateway admin command. You don't have to use Ceph Days Berlin encoder for that thing. And what you get is something like this. Of course, yeah. This S3 object has a size, so like here's 14 megabytes. And then there is a head size. Why is there a head size for an object? Well, we are talking only about the extended attributes, and have seen no data yet. Well, this is a RADOS object. We can still store some data in there, and we can store up to 1 stripe of 4 megabytes directly in the head object, in the first object. So if you have like an S3 object that is smaller than the stripe size, we can store it directly there and we're done. This is just like an optimization for small objects. But if you have anything larger, then we need to use additional RADOS objects. And in case of multi-part uploads, even that remains empty. Let's continue with the manifest. We get some kind of prefix. This is just a random generated ID, so nothing special. And then there is a rules section. And the rules section specifies all the individual parts of that object. So we're looking in the first part. Okay, we've got a part number, so it tells me which part is this. Then a start offset, so if you have multiple parts, then it tells you like the third part starts at offset x, y, z bytes. So we know from how big the parts are. Then the part size, and then the stripe max size. So in theory, you would expect that the stripe size remains the same or all the time. I was wrong, because erasure-coded pools have an API call where you can get the optimal I/O size, and that can change. I don't know when and why. If anybody would be enlighten me, I would be very happy. But just take for now that like the stripe size is not always optimally 4 megabyte, it's 4 megabyte or smaller. That's why we have like an additional member here that can reduce it if needed. And the parts can either be trivial parts, so that's when we don't use multi-part uploads. Then we get just one part with how many stripes we need to get to the object size. But if we're using multi-part upload, then we get exactly one part for a multi-part in S3 protocol. Maybe this is also a little bit difficult to understand, so back to the example. So we have this 14 megabyte objects. I'm doing now multi-part with a 5 megabyte part size. So we would expect to upload this in 3 parts with 5, 5, and 4. And we can do that all in parallel. We can do it out of order. So if we have a look at the first part, then the stripe size limits us to like 4 megabyte. So we need to split. And if you look at the naming schema here, we have like the marker. The marker is again that marker from the bucket instance. Then you have like this multi-part thing, which tells us, okay, this is part of a multi-part. Then we have the prefix that we saw in the manifest a couple of slides ago, and the .1, okay, it's the first stripe. And then, since we need additional stripes, then we have like, we changed to this like shadow thing naming scheme with the 1_1. So it's the first part, second chart. Well, it's all a little bit complicated, but that's how it works. And then we go to the second part. This is also 5 megabytes, so like 4 and 1. And we need a third part, and then we just leave and just need the 4 final megabytes. And that's how you store an object there. Again, this setup, or like how this is organized, allows us to receive all of those parts in parallel and write them to disk as we receive them, yeah. Even out of order. And yeah. That's all the magic of storing data in the data pool. Stripe down a little bit. Apart from that, there are other pools. I have only one that I find important. That's the log pool. The log pool contains the data log and the metadata log if you're doing multi-site sync. The data log and the metadata log track the changes that occur to one bucket or maybe to all of your buckets in a multi-site setup, and is queried by other zone members to know what information they need to retrieve in order to get up to date. So, yeah. And then there is garbage collection. Garbage collection is also like asynchronous and lazy. If you delete an object, it's just like added to the garbage collection queue, and mostly the metadata is deleted. And we store all the stuff we need to delete also in a namespace in the log pool. Yeah, and that's a short overview of how things are ending up in pools and how they are used. And I hope it helps you finding your bottlenecks and debugging stuff. So if you have any questions, go ahead.
The first question, please.
You described the multi-part upload.
Yeah.
Like there are 5 megabyte chunk within, which is the default of S3 CMD, for example. And then there are multiple RADOS objects.
Yeah, multiple stripes.
Yeah, you've got multiple stripes in the multi-part layout, and also stripes inside each multi-part. Is there any optimization which glues them together back again?
Okay, so the question is like, are these multi-part uploaded objects later merged? The answer was no. Because it usually makes not a lot of sense. All RADOS Gateway needs to reassemble the object is like reading that manifest. And the manifest has like one entry for each part that you ever uploaded. And then it just needs to retrieve the objects. And it can do that now in parallel. That's what you want to keep in mind. The stripe size is 4 megabytes. For example, if you like have a gigabyte object that has been uploaded as one thing without multi-part, then it's striped in 4 megabyte chunks, and you can request each of those 4 megabyte chunks in parallel and just push it out to the client. But it's never merged in that sense.
Yeah, but if you upload it in 5 megabytes multi-part chunks, there are double the size of required objects actually, because you've got 4 megabytes and another 1 megabyte somewhere else over the OSDs.
Yeah, you get more RADOS objects from that. That's true. Yeah.
Is this has this scheme of partitioning an uploaded object and the multi, has this changed over time?
Possibly yes, but I don't know. I didn't check the commit history.
Because there was always a warning on the mailing list that you get very uneven use of the PGs with S3 storage. Or you run the risk of getting very uneven distribution, which is moderated with the balancer right now. But is this still the case? Is this still a risk to have in mind and maybe mitigate about it?
So, to my experience, not in the data pool, because like you have seen, like all these objects are named differently. The parts, so they get hashed to a different PG and then it should even out. The only caveat is certain edge cases, for example, with versioned objects. At least in the bucket index for versioned objects, it can happen that the bucket index shards are not evenly distributed because the same name is hashed again and again and again. But for data, I'm not aware of such a problem.
Yeah, thanks.
Hi, thanks. Very interesting insight in the storage of the objects. I am wondering, what are your insights on the mysterious and dreaded large OMAP objects?
Yeah, well, you have all known these, like the number of shards for a bucket. There's a default in the multi-site configuration, that's 11. And if you don't change it or don't have dynamic bucket index resharding enabled, the number of entries per shard grows. And finally, the RocksDB that is backing this OMAP is exceeding 1 gigabyte in size, and then you get the warning.
Well, as a follow-up to that, so we do have automatic resharding enabled, and we see it's kind of working, but still we get lots of large OMAP objects that don't seem to clear until you do a manual reshard. And I know I'm not the only one. Some people here.
Automatic reshard has guardrails, or dynamic bucket index resharding is the feature code, I think. It has guardrails. There's a maximum number of shards it can do. And if it won't even attempt if it's past that number, because it even can't. There is a fixed list number of prime numbers hard-coded in the code. Second, there's a time limit for resharding. And if resharding is, I think it's by default like 10 minutes. If resharding is not complete within 10 minutes, it's aborting it. And then you have to do it manually. And there is this caveat of versioned objects. If you have a different version of an object, it ends up in the very same index. So if you have like one object, theoretically, has not happened to us, where there are multiple millions of versions of the very same object, they end all up in the very same index. And the dynamic resharding is not prepared for this, because it assumes that the objects are evenly distributed among all your shards. And this breaks the assumption. Also, dynamic bucket index resharding only looks at the bucket stats with the number of objects and takes that as a basis. This is also incorrect for incorrect assumptions for versioned objects, because they produce a lot more entries in the bucket in the OMAP.
Interesting, because we do see buckets where the number of shards is way below the max. and it does not automatically reshard. So I guess that needs more looking into by me or the developers. Anyway, I have another...
Yeah, so thank you for the talk. Following up actually on the question of bucket indexes, since you're providing a public cloud service where end users can just upload anything, do you charge them extra for storing small objects? Because the overhead for a single object is quite large.
There's a minimum build for an object. So you can, if you're using especially small objects, you're paying more for that in comparison, and that's to discourage you to don't do this. It's helping, but it's not eliminating it.
Because the bucket stats only tell you the amount of buckets or objects in a bucket and then the total size of the bucket, but it doesn't tell you anything. So you wrote something in addition to this for your billing?
Yeah, the minimum billable amount. There's a minimum billable amount. So an object is like built at a minimum of 64K, but I would need to check.
Thank you.
Thank you. Hi, thank you for the talk. You mentioned extended attributes and object striping. I noticed something in Ceph, but I guess probably related. So I know the max object size, which is the 4 MB, and then you have additional to that, you have the stripe unit and stripe count. Am I talking about the same striping you mentioned?
What is your question?
Sorry?
So what is your question?
My question is, what's the difference? So if I have the max object size 4 MB and I am writing a 15 MB object, then it's going to be split in 3 objects on RADOS. And then how does stripe unit affect that, like the stripe size?
Maybe you're confusing 2 things. Like there's this part number thing, and there's the stripe size. And these are 2 completely independent things. And the parts exist because of S3 multi-part upload. And the stripe size is a maximum of what is actually stored as a RADOS object on disk.
That's the maximum object size.
The maximum RADOS object size saved,
Yes.
Because there's also an S3 maximum object size. Not to be confused with.
Yeah. Stripe unit, does that tell you something? I know there's an extended attribute on objects. It's FFS, I'm not sure about RADOS. That is the stripe unit, which is not the same as the max object size.
Yeah, well, this is, do you mean the thing in the manifest? There's a max stripe size in there?
That was the object size, right?
No, this was not the object size. There's also a max stripe size in there.
And that wasn't the 4 MB, the default?
It can be lower than that.
But that is the same value?
It can be the same or lower.
Is this controlling the same thing in the backend?
This max stripe size there, I actually looked up it in the code, is it tries to optimize it for I/O. That's why we are using striping anyways. So we take the optimum I/O size and stripe it according to the optimal I/O chunk size, whatever. That's what the Ceph code does there.
So when a client is coming to write a 15 MB object, there will be splitting based on the maximum RADOS object size, and then another splitting based on the stripe unit.
No, it splits according to the stripe size.
One splitting.
Yeah, if you don't use multipart.
Okay, yeah, the multipart thing is... Gotcha.
Yeah, the multipart thing is confusing, I know.
Yeah, but it's something different just about the related to the upload.
It's another abstraction.
All right, so maybe we can go with this discussion then to the food truck or somewhere else. Your time is over. I'm really sorry. Tobias Brunnwieser, thank you very much for this enlightening talk. Thank you.